All right, so balancing chemical equations. The thing I would always suggest to do first is count up how many of each atom type you have on each side of the equation, reactants versus products to begin with, and then I would aim to change the coefficients of the most complex species first and leave something easy to fix till last. Okay, so if you have like a single element or a diatomic or whatever, leave that till last. So we've got 2 hydrogen atoms on the left side and we've got 4 phosphorus atoms on the right side. Okay, and remember, whenever you change anything, you need to update your accounting. So we've got 1 phosphorus on the right side and 3 hydrogens on the product side. Okay, so I want to just try and get this pH 3 looking okay to start with. So I think the easiest thing to do would be to sort out we've got an H3 here and H2. I'm picking on that because I've got an even number on this side and an odd number on that side, and that's always a little bit painful. So the easiest way is to find the lowest common multiple. So I know I've got 2 hydrogens on this side and 3 on this side. So if I do 2 times 3, my lowest common multiple is 6. So if I can get the number of hydrogen atoms equal to 6 on each side, then that's going to make things a little bit easier. So I'm going to want to multiply this side by 3 to get H2 to give me 6 total hydrogen atoms. So just remember as you go to update your accounting. Okay, so now I've got 6 hydrogen atoms on this side. And I'm going to do the same on this side. This time the coefficient I'm going to need to add is 2 in front of the pH 3s. Remember, you always just change coefficients. You never mess with subscripts. Okay, now because pH 3 is a compound, I not only have to adjust my number of hydrogens, so 2 times 3 is 6 hydrogens, I've got to adjust my number of phosphoruses, because now I've got 2 phosphoruses, right? So 2 phosphoruses right here. Now, there's 2 ways you could go from here. Okay, you could say, hey, I've got to times this by 2 again to get the right number of phosphoruses. Okay, which then means you've got to times the H2 by 2, etc., etc. Or you could use the fractional coefficient method. Okay, so I guess I'll go through both. Okay, so if I write it out again, if I'm like, oh, I'm gonna have to go to having like 4 pH 3 on the right hand side here in order to get the right number of phosphoruses, so then I've got to, well, if I've done that, I'm going to have how many hydrogens? I'm going to have 4 times phosphorus, which is what we were hoping for, and I'm now going to have 3, 6, 12 hydrogens. Okay, so I've got to fix the left hand side, which means I'm going to go 6 H2 plus P4. Okay, so I can do that. Okay, so now I know I've got 12 hydrogens and I've got 4 phosphoruses, so that matches, right? So I could do it that way, or I could have taken this and been like, well, I'm going to put a half fractional coefficient in front of the P4, the 2 pH 3. Sometimes people find this a little bit easier to visualize. Okay, so at that point I would then have 6 hydrogens and I would only, hey mouse, updating my accounting from earlier, I would only have 2 phosphoruses then, because half of P4 would give me 2 phosphoruses, and then I'd have my 2 phosphoruses over here and my 6 hydrogens over here. So again, that would be balanced, but the convention is not to have fractional coefficients. So if you do use a fractional coefficient to balance, just remember you're going to have to times that whole thing by 2 to clear the fraction, and then guess what you end up with? Or 3 times 8, 3H2 times 2 is going to be 6 H2 plus P4 goes to 4 pH3. So you get the same answer regardless of which way made more sense to you. Okay, I wanted to show you both because some people find using fractionals more just like the way your brain works, and other people like to be like, oh, I'm going to times that by 2 and then that times that by 2 and keep working it through. Okay, let's have a look at another one then. Okay, so I don't want an explanation. I want another problem. Give me another problem. Show another. Tip. That's the same problem. No. That's still the same problem. Hello, Alex. Give me something fun. Okay, so here we go. All right, so again, we always start with accounting. Okay, so let's separate our reactants and products side. Okay, so on this side, I have 1 sodium. And and I've got 2 oxygen atoms, and then on the right-hand side, I've got 2 sodium atoms, and I've got 2 oxygen atoms. So the oxygen's okay, and the sodium is not. And this one's actually a very straightforward fix, because if I just put a 2 in front of the sodium, then update my accounting, I should be a-okay, right? Now I have 2 sodiums, 2 oxygen, 2 sodiums, 2 oxygen, and that's all there is to it. Okay, I think that'll do.